This evening we're going to have a demo called the Genified molecular sensing and control. This evening we're going to have a demo called the Genified molecular sensing and control. We built an open resource platform to enable innovation, design, the practical emulation related to molecular network. And in this demo, we are going to give an overview of our platform and want to highlight our latest finding and observation. And please stop by and give our comments. Thank you so much.
Table number 2, Francisco Ronzino talking about mobility first. He's from Rutgers University.
Hello. So we are planning to showcase in our demo how we plan to support in the mobility first future internet architecture, flexible extensibility of data plane services through the use of a pluggable compute plane in the network. In particular, using Genie resources, we're going to show how a video service provider could plug a transcoding service inside the network to strategically transcode video streams, adapting to the bitrate available at the edges of the network. Thank you.
Table number 3, Zongling Fei from Kentucky talking about Genie Desktop.
We'll give a demo about Genie Desktop. Genie Desktop provides a unified interface for you to create, interact, control, manage your experiments. Also can measure the performance of the experiment. In this demo, we'll show the newly implemented function such as stitching support and slice membership support, enable you to add new users to your slice, routing support, and the SDN user-defined route support. If you are either an experimental or developer, come to see our demo. Thanks.
Ray Lito talking about simulation as a service. Table number 4, Ray's from TotalSim.
Hi, I'm from TotalSim, working with the University of Missouri, Prasad Kaliam. We're going to show hybrid cloud experiments using Genie. The main purpose for us as a company is using virtual desktops and then delivering those desktops as a service, simulation as a service, and trying to build a platform for our customers to remotely access things quickly.
Derek Meyer talking about WiMAX connectivity and monitoring. Derek is from the University of Wisconsin.
So the project that we're working on here is we're bringing a little warm and fuzzy to Genie's hardware and software world. We are Genie enabling a natural resource station out of Wisconsin. We use the Genie wireless resources to give them wireless access to their experiments, and the dynamic routing using OpenFlow through to the Genie rack, the InstaGenie rack that's over in Madison, Wisconsin. So if you're interested in some of the network architecture that we're working on out there and some of the experiments that the natural resources students will be using. Thank you.
We have Vitaly from the Applied Research Center for Computer Networks, Moscow, speaking about a network prototype simulator.
I would like to produce a distributed network simulator based on lightweight virtualization technique called network prototype simulator. This system is intended for network operation analysis and network application and protocol development. It's a scalable solution to perform a complex experiment with 10,000 hosts. So it has own specially developed graphical user interface and specially created network application configuration library. And it's an open source project, and you're welcome to demo this today's evening. Thank you.
Also from ARCCN is Sergey Monin, Eugene. Eugene Singh, table number 6, speaking about verifying monitoring for SDN.
Thank you. If you want to ensure your control plane your control plane rules the switch in such a way a network works as you intended, you should be interested in our tool called Vermont. Vermont is a watchdog for a network. It checks the compliance of the forwarding rules loaded into the switches with a custom set of high-level network-wide policies. You can define your own policies unique for each network. Vermont runs on the fly. It prevents violations of your policies and gives you sensible information about the sources of these violations. Welcome.
Also from ARCCN is Sergey Monin speaking about Universal Wireless Controller Chandel, table number 7.
Thank you. Hi, we would like to introduce to you our solution for high-density wireless network management Universal Wi-Fi Controller Chandel. Our controller allows centralized management of access point from different vendors, integration with SDN infrastructure for effective client roaming, unique algorithm for dynamic radio resource management and load balancing, and geographic sensitivity ability to actively oppose external threats, participate into Wi-Fi wars, and many others. Thank you.
Alexander Shalemo, also from ARCCN, he has 2 demos he's going to be talking about, so he gets 1 minute.
Hello, I've got 2 projects. First one is called EasyWay. EasyWay is a next generation open floor based network management system. You no longer need to manually configure each single devices. You can just simply draw the path through the network and the open floor controller does the rest. We also introduced high-level abstractions, new high-level abstractions. Instead of IP addresses, subnets, and routes, so we can use names, groups, and passes. So we call this approach as semantic control. I also would like to present RCCN, a network high-performance platform for network function virtualizations. It allows you to run high-speed networking services on commodity hardware, manageable from centralized orchestrating systems. There are 3 main features. It's high-performance data path, reduces overheads, networking overheads in commodity servers. It's advanced scheduling algorithm in order to identify where to place new services, and automatic service scaling based on load information. Thank you. Well,
Table number 9, Yifeng Wang of Boston University talking about video streaming over Proto-RINA.
RINA is our recursive, closely recursive internet architecture that inherently solves the problem of the current internet. So Proto-RINA is our prototype of the RINA architecture. In our demo tonight, we are going to show how Proto-RINA can be used to support video applications on legacy hosts and achieve better performance through flexible RINA policies.
Satyajit Padmanabhi, table number 10, speaking of University of Houston, speaking about simulation detection and denial of ping attack.
So the defense mechanism is needed against ping of death, which is a denial of service attack, which is caused by deliberate ICMP packets. So we utilized a GIME framework to measure and stop the ping attack by inserting a deny flow rule into open flow forwarding plane. The measurements and results will be on LabWiki when you stop by my demo tonight.
Also from University of Houston, Atik Kumar, table number 10, speaking on end-to-end flow manipulations and network debugging.
We created a tool that performs flow separation at traffic aggregation points. We program open flow switches that with filter arguments for match fields. We created a demo topology on Genie using VTS, and we were able to filter out any header fields so network engineers can perform end-to-end debugging. We increased granularity in analysis similar to how we utilize Wireshark.
Also from University of Houston, Long Tran, table number 11, speaking on measurements of forwarding performance of the link software switch.
Hello. We are just in characterizing the performance of 2 software switches, programming like the LInX switches. Then we measure the flow system time and the packet forwarding speed for each switches. Our findings will provide insights into performance characterization for software switches. Okay, thank you.
Jim Martin, Clemson University, table number 13, talking about Sci-Fi 9.
Hey everybody. So at the booth, we will show and talk about SciYnet, which is an MVNO. We are reselling Sprint's 3G, 4G data services, and the point for this GEC is to show how Genie Wireless and our community can be extended over commodity networks using SciYnet.
Samuel Farrington, NYU, talking about Genie for the masses.
Hey everyone, so we're going to be demonstrating the set of materials for educators in the massive open online course format. It's going to be intended for a broad audience with little to no technical background required. In each MOOC module, there will be an experiment that's run on the Genie infrastructure, and where students can execute and analyze their entire their experiment in the browser by itself. So some of the topics that we'll be doing are adaptive video streaming, Bitcoin, software-defined networks, net neutrality, public key cryptography, and routing. So thanks, stop by.
Ben Newton, University of North Carolina, Chapel Hill, table number 15.
Our demo is going to include two parts. First of all, the Genie education modules that we're developing for undergraduate level networking classes for any university, and using Genie assets to do simple networking tasks for these classes. And then also TMix, which is a software product developed at UNC to do realistic generation of network traffic off from empirical measurements. So measuring.
Lee Liu, UC Davis, application of our big data, table number 16.
We will have 3 different demos this evening. The first one is the application of our big data demo. We will show a SDN-enabled optical switching node to dynamically switch 4K signals. The second one is dynamic Wi-Fi handover demo, and the third one is a multi-domain SDN demo. We will deploy and show a broker-based multi-domain open broker control plane, and we will have a multi-domain display from UCT campus to content to ESNet. Thank you and welcome.
Tumidu from University of Idaho, table number 17, virtualized services via SDN.
Thank you. Tonight we'll be demonstrating a framework for providing applications via software-defined networks. And what we'll be demonstrating tonight is a first implementation of our framework, and you'll be able to see through network virtualization from the service provider to the end user. And the end user will be a completely thin client, so all the resources will be on the server side. And the network is controllable because it's SDN, and we are providing dynamic priority-based packet forwarding and so on and so forth. And I hope you come and see it, and I hope everybody will be able to use our framework in the future. Thank you very much.
Table number 18, Michael Zink, University of Massachusetts, which we're talking about virtual computer networking.
Good. Oh, you're taping me. Okay. Good morning, everyone. If you're teaching computer networks in the spring or the fall or spring next year, come by our table. I can tell you a little bit more about this. We're going to present a lab we created for undergrads, actually just taking an OpenFlow switch and use that to teach them how Ethernet switches actually work, using something like Big here on top of it to have the students run these experiments. So if you're interested in that and have some teaching assignments in the next year, come by and take a look.
Ronnie Lumba from the University of Minnesota, talking about Genie Viro, table number 19.
Yeah, hello everyone. In our project, we implement Viro. Viro is a virtual ID routing protocol as a known IP service in Genie. We have implemented the initial prototype of Viro in Genie, and in our demo, we're going to show how Viro works and how Viro handles switch failures and host mobility. Please come and see us.
Here, speaking about the Genie.
US Ignite.
Oh, sorry.
At GEC 19, we showed you how to run Hello World across Genie in less than 5 minutes. In GEC 20, we're going to show you how to run a real experiment to evaluate the Google Global Cache in less than 50 lines of code. only a few lines of coordination and orchestration code, and all from your desktop. And we'll show you how to read and write the data. Write the data on a node. Read the data on your desktop as if it was a single file system. Come by our demo. Thanks. Bye-bye. The Genie Experiment Engine.
Rob Ritchie, table number 21, JAX.
So we'll be showing off JAX, which is the GUI that we're building as a successor to the flat GUI that many of you have used. It's built more around the user experience that we want to provide people rather than the Genie architecture. And we'll show an integration with that in the portal. The real reason you should come, though, is that we can't keep the names JAX and ACT separate either. And so if you catch us saying JAX, we mean flat or vice versa, you can get entered into a drawing to win this T-shirt.
No rights. Aki, University of Tokyo, speaking about Vnode table 22.
Today I'll show flexible video streaming via application-specific threads on Vnode system. And we can put needed functions dynamically depending on situation to deliver optimized video streaming. Like this, we research new killer application to make full use of programmable networks such as Vnode and Genie. So please come our booth and discuss together. Thank you. 22 Vnode.
Sorry, there was a glitch. We brought 4 demos and we divided work into 4 people. So he gave a Vnode and I'm giving 23 Flare. So the Flare is a deeply programmable node and we can program data plan. And tonight we try to show a killer app of software-defined programmable network, and you can judge, come to our table and judge if it is really a killer application or not. What we are showing today is an application-driven software-defined networking, and which means that instead of specifying flow, pattern match, and action, such as in OpenFlow, we can do application name, application status, pattern match, and actions. Thank you very much.
I'll give you a presentation about condition avoidance technology in a video transmission. In existing explicit routing technologies, complexity grows in cases where the number of flows is very large. Our method can reduce the complexity by automatically combining multiple virtual networks of different topologies. Thank you.
Table 26.
Today, we federated 3 domains by using our federation method. One domain is a Proto-Genie agreed in University of Utah. Other 2 domains are Vnode infrastructure in Japan. These domains are federated through a slice exchange point or SEP, which is a similar concept to SDX. Slice developers can request a slice only to one domain. Then the slice is spread among the 3 domains. Thank you.
Table 27, Sujay Yintran from Rochester Institute of Technology, OpenBids.
Hello. We have embellished OpenBSwitch to act as NIDS. So we offer no overhead to the data plane. We have scalable and modular architecture. And we have plenty of results with the snot. So we have a good architecture. Please do drop in.
Table 28, Greg Gordon from the University of Kent, talking about Fire Genie SDX.
Good morning. We have created the first prototype of an SDX, which has been used for layer 2 interconnections in Europe and between Europe and the US. So that is what we will show at the demonstration. So if you are interested in international connectivity or international federation, or if you want to see how easy stitching can be done for an experimenter, just come by. So at this very moment, Belgium is playing soccer in Brazil. So you see my priorities are really at this GEC.
Here, Victor speaking about Genie Fire Federation. Table 24.
Thanks. Good morning, everyone. So with my colleagues from NICTA, IMINES, and UMass, we'd like to show you this evening how we can use the powerful LabWiki tool to easily design and run an experiments using hundreds of nodes, both from Genie and Fire testbeds. So it's going to be this evening, table 24. Please come and see us. Thank you.
Mohammed, University of Kansas, speaking about network resilience using overflow. Table 29.
Hello, everyone. Basically, in our demo, we will add a set of constraint links to OpenFlow switches, and this will be based on maximizing either like algebraic connectivity or path diversity. Then we will attack these switches by removing based on centralistic based, such as betweenness or degree, and we will examine the resilience.
Jim Chen, Northwestern University, table number 30, software-defined network exchanges.
We're going to talk about the current status of different software network exchanges we are working with. This is included with our partner SOX as well as international. In addition to that, we also have a partner with a corporate. They have a testbed, which we will announce that, and which is Sienna, our partner here. We will work with a different partner and work with their requirement for different type of exchanges and make them work together.
Edgar Kissel, Indiana University, talking about intelligent data movement system. Table 31.
Great, thank you. Good morning. So IDMS is essentially a distributed storage service running on Genie. It consists of a bunch of interconnected long-lived slices, and we use things like shared VLAN, stitching, custom images, and we have some very interesting techniques for distributing the data across the experiment, as well as optimizing the transmission of data between the object services themselves, or the storage services. And we will also be showing how a user can attach to the existing slice and use the service to upload and download their own data. And if any of that is interesting to you, please come by and see our poster. Thanks.
Paul Root, Red Sea, table 32, Genie Science Shakedown.
So the Genie Science Shakedown project is aims to evaluate Genie's ability to support domain science applications. So tonight what we're going to demo is the AdCirc storm surge model, which is an MPI application running on both InstaGenie and ExoGenie. Show you how to do that. And we'll also show you a bunch of work we did to port custom images between racks and to snapshot custom images in ExoGenie. So,
William Balding, Red Sea, speaking about ExoGenie features.
Hi. So at ExoGenie, our main goal is, of course, enabling your experiments. So we just brought in a few new features that you might find interesting. We have a new facility to enable easy snapshotting of images. You can make new images much easier now. We are also bringing in, hopefully, a demo of 40 gigabits per second on ExoGenie, if that works. And if you're looking for powerful resources to run your experiments, we have new racks with larger number of cores, faster CPUs, and faster networking in them, and SSD drives. So if you're looking for resources for your experiments, come talk to us.
Russ Clark, Georgia Tech, table 33, SDX LG.
All right, you've heard about the SDX, the software-defined exchange. Come see one of the ways that Genie is working to make SDX a reality and make it available to you as researchers and experimenters. Most importantly, you don't have to hear it from me. We have one of the developers of the project, Arpit, is here. You can ask him all the hard questions. Remember to vote 33. 33.
Table 34, Genie Cinema, Benton Cripps, Clemson University.
Hey everyone, Genie Cinema is a service similar to an improved actually version of YouTube. We hope to allow professors to upload video to multiple VLC servers across the nation, and then students anywhere in the nation that want to view the videos can connect, and Floodlight will dynamically determine which server to connect them to based on the lag and anything else, and that way we can give them the best experience that they can get. If that sounds interesting, we hope you'll stop by table 34 at Genie Cinema.
The next four are posters. Denise Gurkin has two. She'll be talking about measurements of netmap-based data plane acceleration, integrating Dell STP into Genie.
So NetMap, XTPD is the extensible data path daemon developed and maintained by our collaborators in Germany, BISTN. We integrated the NetMap zero-copy framework to achieve acceleration in the data plane of XTPD. Performance characterization is challenging when the software that is used to generate the traffic is also measuring the performance. So come by our poster to discuss more. Our next poster is STP. Split data plane provides a port expansion for a specialized networking hardware inside a pizza box switch. Dell is donating 10 such boxes with KVM network processor units to Genie. We present aggregate manager considerations and our progress in integrating these boxes to Genie. Come by to see.
Cheng Wang, Catholic University, also a poster.
Okay, so we have a poster for a reliable communication protocol designed using OpenFlow technology to establish multiple disjoint paths and continuously monitors latency. And if the latency found or the path loss found, we will establish a new path to continuously monitor our path reliability. So this technology can be used for the advanced manufacturing and CNC.
Don Montcraft from Rochester Institute of Technology, also a poster.
Good morning, everyone. So we are working on tools and softwares to analyze end-to-end security and performance for cloud providers. So what we do is we analyze the routers that are between the user and the cloud provider VM and try to find out the routers that have the best security or performance, try to find out the best route between the user and the cloud provider, and which cloud provider has already best routes. So that's it. Thank you.
Thank you. Let's give a hand of applause to all of you. Please don't forget to vote at the demo session. There will be ballot boxes at a couple, 3 or 4 different places. There will be ballots at the demo session if you don't have a ballot. So hope to see you all there. Thank you very much.
Rick, should I stop this? Sarah, should I stop this?